Good day, everyone. So today we shall be looking at magnetism. Magnetism. We are going to be looking at some concepts about this topic, and at the end of the day, we shall know what magnetism is about. Let's dive in. The concept of magnetism. Of course, when we talk about magnetism, we must talk about the root word magnet. A magnet is any material that is capable of attracting other pieces of the same material as well as piece of iron. So any material that can attract another same material or attract a piece of iron is known as a magnet. And we have some substances that can be attracted by a magnet. These substances are called magnetic materials. Any material that is attracted by a magnet is known as magnetic materials. An example of such are iron, cobalt, nickel, and some certain alloys of iron. On the other hand, substances that cannot be attracted by a magnet are called non-magnetic materials. They are known as non-magnetic materials, and we have examples like brass, wood, copper, and glass. Okay, now let's talk about the properties of magnets. First of all, this is a sample of a magnet. The end of magnet has two poles that are known as the north pole, represented with capital N, and the south pole. Okay, now when you bring one magnet that has north and south pole towards another magnet that has north and south pole, and you bring their opposite end close to each other, they are meant to attract. That's a law of magnetism. Opposite pole of magnet attract, while same pole repel. So this is the major property of magnets, that when you bring like polarity together, repulsion will occur, but when you bring on like polarity, attraction will take place. All right, now there are ways of making magnets. We call it magnetization. Magnetization is a process whereby a material is made to become magnetic. So it's a way of making a magnet. And there are 5 ways of going about this. The first way is electrical method. Second way is called the single touch method. The third way of doing that is called the divided touch method. The fourth way is called the hammering in the earth field. And the fifth one is known as the induced magnetism method. Among these 5 methods, we would like to consider the first 3 in details. Now let's look at the electrical method. If you want to make magnets with electrical method, firstly, you have to get a material known as solenoid. Okay, now let us watch a little video on this, on how it works. Now when you get a solenoid is a copper wire that is wound around a magnet. So you put a bar magnet, for example, you put a soft iron bar, the material that you can use to make magnets, either a steel or an iron bar. You put it inside the solenoid, that's a copper wire that is wound around it. And when you do that, you connect the solenoid to a battery. As the battery is supplying current into the solenoid that is having the steel or the iron bar, automatically the iron bar becomes magnet. Now, how do you know the north and the south pole? When you view the direction of the flow of current and you find that it's going in the clockwise direction, then that direction is known as the south pole. But when you view the flow of the current and it's blowing in anti-clockwise direction, that direction where you are viewing it from is known as the north pole. So in summary, to make a magnet by electrical method, you connect a steel bar or an iron bar to a solenoid that is connected to electricity, and it becomes a magnet. This is the electrical way of making a magnet. The next method of making a magnet is what we call the single touch method. How does this work? Let's play this and see. All you need to do is to get either the steel bar or the iron bar, and then you get a magnet and stroke it. You stroke it from the top down and lift it high again. Continue the process several times. As you are doing that, the point where you are stroking it from receive the North Pole, and the other side receive the South Pole. Okay, so the polarity of the magnet where you stroke it from will become the polarity of the steel or the iron. You do it on the first phase and the same way on the second phase of that steel. Automatically the steel becomes a magnet, or if it's an iron you're using, become a magnet. Now when you use a steel bar to make a magnet, what you will get is a permanent magnet. But when you use an iron to make a magnet, what you get is temporary magnet. So this is the single touch method. We call this stroke method, single stroke touch method. Now when you use this method, you make a magnet. However, the disadvantage of this method is that the polarity of the magnet is higher at one end than the other end, because you are applying the stroke at one end more than the other end. So having said that, let's consider the third method of making a magnet, and that is the divided touch method. In this method, you have two magnets on top of a steel bar or an iron bar. In this case now, when you are stroking, you stroke the two magnets in this way. Can you see? In their opposite pole, and then you stroke it downward that way. You repeat this pattern several times, and as you do that, the steel bar becomes the steel bar get the opposite pole of the two magnets we are using to stroke it, and that is how you can see that North Pole here while you have the South Pole here. That is exactly how to make a magnet using the divided touch method. So in this case, instead of using one magnet, you use the word two magnets. Sometimes it is called a double touch method because you are making use of two magnets. Alright, having said that, let's talk about how to also demagnetize a magnet. We just talked about how to make a magnet. You can also choose to demagnetize this magnet. When we say demagnetization, it's a process whereby a magnet is made to lose its magnetism, and it can be achieved through electrical method as well, mechanical method, and heating method. So let's consider the mechanical method or the electrical method. If you are going to demagnetize the magnet by electrical method, just like we did it in making a magnet, but in this time around, the source of electricity will be AC source. An AC source of electricity will be connected to the solenoid which is having the magnet. When you do that, this time around, instead of you having a steel, but you're having the magnet itself in the solenoid, and now the solenoid is connected to AC source of electricity, not DC this time around. Remember, the first one was DC, but in this case, to demagnetize, you use AC source of electricity. And when you do that, after some time, the magnet will lose its magnetism. So this is the electrical way of demagnetizing a magnet. The next method of demagnetizing a magnet is called the mechanical method or the heating method. Now, when you talk about the mechanical method, it's like getting an hammer and you are hitting that magnet with an hammer. When you are doing that, gradually the magnet will lose its magnetism. However, the heating method is by subjecting the magnet to heat, bring it under fire. When you leave it inside the fire or inside heat for some time, it will also lose its magnetism. So these are the three different ways of demagnetizing a magnet, either by electrical method or mechanical method or the heating method. Either of the three will make the magnet to lose its magnetism. All right. Now, earlier on, I've talked about temporary magnets and permanent magnets. Temporary magnets are magnets that can retain their magnetic properties even without an external magnetic field, such as electric current. When you remove external magnetic field like electric current or electric current rather from it, it will still retain its magnetic properties. That's how you know a permanent magnet. It always retains its properties even without an external magnetic field or electric current. And the material for making this permanent magnet is steel, and that is because steel produces a stronger magnet. It produces a stronger magnet that maintains its properties of magnetism even when there is no external magnetic field. On the other hand, we have what we call the temporary magnet. This magnet only exhibits magnetic properties when placed in a magnetic field. In other words, when you remove the magnetic field from them, they no longer have their magnetic property. In other words, they are no longer a magnet. So they are just temporary because there is magnetic field around them. And the material for making this kind of magnet is iron. So sometimes we call temporary magnet electromagnet. Then magnetic field. Magnetic field simply is a space surrounding magnet in which magnetic force is exerted. Okay, the space surrounding magnet, because see this space here, this line represents the magnetic field, is known as the magnetic field. The space surrounding the magnet in which magnetic force is exerted, and it is a vector quantity. That's because it has a specific direction. Okay. All right. Now I haven't talked about that. Let's look at another concept in this magnetism, and that is the meridian and the angle. The meridian in magnets are just vertical plane that passes through either through the earth north pole and south pole or to the magnetic north pole and south pole. So we have two types of them. We have the geographic meridian, that's the geographical plane that passes to the geographical north and the geographical south of the earth. While the other type of meridian, which is the magnetic meridian, is the vertical plane that passes to the magnetic north to the magnetic south. You see here now in this diagram, you see this north south. This is geographic meridian. Why this other one is the magnetic meridian here. Now the angle between the geographic meridian and the magnetic meridian is called angle of declination. And then why the angle between the geographical meridian and the horizontal is called the angle of inclination, or sometimes we call it angle of dip. So we are going to be drawing the curtain here on the concept of magnetism. Thank you for listening. Bye for now.